Sure.
So, good evening, everybody. Today, Dmitrii Rudenko will speak about Kaggle competition to predict the student performance from the gameplay. It's a very interesting competition which was recently finished, and Dmitrii will present us a review of this competition. Thank you very much, Dmitrii, that you agreed to make a talk, and please start.
Yeah, sure. So, predict students' performance from gameplay was a competition to predict students' answers for questions, like if they were correct or not, from event data. Event data was based on some kind of open source app, which were developed for educational purposes, and main fraction of users were just average kids in their 13, 14 years old as assessors in these terms. So the goal of this competition is to build a better, a nice model which would predict this performance and introduce some insights for organizers. What can they do better? How they can better build their apps in future to improve learning process. Long story short, let's stick to the first place. This competition was kinda easy to solve in terms of not the only you could just use XGBoost and CutBoost to predict everything and still get a bronze medal or something other. But on the other hand, it was really challenging because when you have such kind of data in such an easy trained models, you don't need any resources to pre-train, and you got a lot of people trying to solve this competition. So you have a very low entrance paywall. But the main and the best solution had a great story behind, because these guys were trying to solve this competition from the very beginning, and they found 2 data leaks and proudly reported them to organizers. Organizers have changed data sets several times. Organizers have changed API several times, but it haven't really helped because they haven't finished fixing the last data leak, which was reported to them. And that's how the first place got their place. They just found out which kind of data leak is available at the data set. So the main idea of the first place was in self-created validational schema. They looked at the trained data and found out that there are not too much data points. They tried to find some other data sets and found publicly available data sets from organizers in a slightly different format, but they really could use it. So they spent kind of a week for the data aggregational pipeline, which could provide them some more data. And they succeeded. It really worked well. They trained and got trained their model, built it for like a week or 2, and achieved the first place at the competition, by very early submissions. They found it very strange because they could achieve kind of 0.705 at the like their validational schema, but got 712 at the public leaderboard, and for sure got a very nice score. You can already know that the best public score right now is 707, which is even less than they got, and they reported this like invalidance between training validational split and this testing split in this inconsistency. And competition organizers just said, yes, okay, looks like we got a leak. We will change the test and train data to like introduce better competitional spirit. And in the end, finally what they did was just they have deleted a part of this publicly available data and used it as a private and public data set for validation. But as far as first place have like already copied the initial data set, they could achieve some part of some part of tests for public and validation, tests for public and private. They didn't really know which part and how was it processed, but they have like sources for this private set. And it was a leak. They also reported it that they know this thing, but organizers didn't do nothing. They really just closed their eyes and yeah, provided like a chance to win this competition to these guys, so they won. But they got a relatively nice data schema and very nice insights. How should you set up your validational pipeline in these terms? So what they did, they experimented with validational fault size and found out that if you, for example, would use 10 faults, you would have a very small faults with relatively high variance between them, which is not good for like estimate of model fit. So they experimented with it and found out that 5,000 sessions between in fault could be a nice estimate because you have a low variance between the faults. So you might think that every model really fits in a like consistent manner. And from the other side, they settled up like enough faults to have an averaging, to have their like average score between models, which usually boosts performance because you are just trained in computational power in terms of bias of your like smaller sets. Another great thing they found is that first at the scoring time, data sets like competition organizers API were just scoring private set and then public set. So you could for sure like hide on the leaderboard if you have a really nice results and don't want to push the like competitorship. You could really just predict public part and predict constants on the public set if you're just a lover of great shakeup. Another thing which can be useful for you guys is recursive feature addition. usually people generate a lot of features, and this competition wasn't an exception. The main problem here was that you could really generate several thousand different features, and everyone would be somehow useful. Model would change, choose it, and provide some kind of importance for it. So what they did, they really started recursive feature addition process, adding only features which for sure improved their score on validation pipeline, of course. And that's what they did. They found out that they have some external data and they didn't want to really overfit on it. As far as they use it as a part of their validational pipeline. So they tried to be like conservative and used recursive feature addition, which is kind of most conservative way of feature selection. Usually people just shrink, and as Vadim Kamayev did, usually people just shrink some useless features to improve their score, improve model stability. Not that time. They also used polars as a feature preprocessing pipeline, which is a really useful library for data preprocessing. Please try it. It's really great right now. It was kind of worth it, 2 years ago to try when it all have already started, but not today. Today it's literally bugless and very fast. Okay, you can find some bugs. You can also contribute on it. Please go on. You will help the community and make someone happy. You also will have some contribution in a really popular library. So basic model which they used was XGBoost. XGBoost really got the best results in this competition. I wonder why, because usually people can train LightGBM, and LightGBM usually have literally the same performance as XGBoost, but just faster. In this competition, people really used XGBoost only. I have found only one nice solution with LightGBM, which got some silver place. As a model, guys really done a great work. They tried transformers. Transformers really didn't work, and also took too long to train. They say that they had kind of 2 hours of training per fault, which is not the best way to really iterate fast as far as you have a great validational pipeline, which highly correlated with public and private leaderboard. So they just screw it up and moved to convolution 1D, which is just convolutional neural network over RNN encoder. They spent just 2 days to set up model pipeline which would comparatively work as XGBoost. They say that they got kind of 200 experiments for their convolutional 1D architecture to settle up proper hyperparameters, figure out how many hidden layers they need for this convolutional scene. But yeah, it was really fast. They say they got speed improvement 10 times. So instead of 2 hours, they could just wait for 10 minutes per fault, which is nice speed because you don't want to like have instant results, but on this, especially on this amount of data. But yeah, iterations for full pipeline less than an hour, usually nice thing to have. So yeah, guys, one with external data sets they scraped and found first, and which was hidden by organizers, but not for them. XGBoost and convolutional 1D network. They also used out-of-fault prediction, always use it. It's even better than having just one model. It's not that good in production, but for computational reasons, you are not that bordered with resources, so performance is your king. Yes, it's pretty much all about the first place solution. I would like to discuss two more solutions. All other solutions are just, you know, kind of same. The same way was to use external data set. Maybe not that full that first place guys found, but yeah, every winner used it. So, okay. Yeah, second place solution haven't really shown the results. They don't know write-up, so no way to know what have they used. But third place used external data too. They haven't used it in validational data set, and as far as I see by comments, they see it as a problem. Why haven't they got the first place or the second one? Because it really could help, because they got not that stable faults for their validational schema. Yeah, so it was their problem. They have had no feature selection by groups at first. They just decided that all features which we generated are really nice and nothing really extra there. So we will lose everything here and leave everything here and be happy with it. They used prediction probabilities for previous question to like find out how good student was performing. And for other model, okay, that's a stack of 4 people. One of them is a competition expert. 3 other are computational masters. So they just stacked several models all together, which they kind of built independently. So yeah, they used prediction probabilities, some feature selection by permutational score. That's when you just train model, figure out how important features are. Then for some features, you just permute randomly their feature values between objects. And train model again, figure out how would models select this randomized feature. So you got some like baseline for a really random feature and some baseline for real feature. So you can operate it and figure out how confident you are that your feature really gives some boost and really selected by model. These guys used 3 type of models: XGBoost, some CatBoost, and neural network. We'll talk about neural network later. For performance, their XGBoost performed a little bit better on validations than CatBoost. So it's still challenging to settle up CatBoost hyperparameters properly. They say there is some hint which I can share with you. You just can follow CatBoost's Telegram chat, like official one, and ask their developers which parameters could you use. They usually help you with figuring out what can they like, how can you do your model better. But yeah, here XGBoost performed better as in the previous one. They used a relatively interesting schema for XGBoost. They just predicted, they used just 3 models for every like game stage. And for the first game stage, and for second, for the third, they use the same, the one trick. They predicted if the answer would be correct, putting in that question number is a feature. So if you want to, for example, answer for the first question, or for the second one, you would use the same model, but with different feature values for like feature field. They also treated it as a categorical feature, not like continuous one. And they got relatively nice in neural network. They really managed to run transformer architecture, which were challenging for the first place, because first place solution, they were trying to build the best solution and fastest solution. This competition had an extra prize for like the most effective one. So you had to get 1 out of 10, like top 10th place or something like it, and get the best speed of prediction. So yeah, third place were not grounded to this prize, so they used just 3 different transformers. First one was just usual transformer, and 2 other were some variation of conformer. Conformer is a transformer architecture for like with a high attention span for like recent actions. So it kind of uses optimized attention metrics, but forgets this old events. So to stack all these 3 transformers, they just used one bidirectional LSTM, and always used 1 LSTM layer to like really predict which question would be right or not. You can check out the architecture on the slide. Yeah, and after it, they oops, back. Yeah, they used different like model heads. And fourth place, they just used very vanilla setup. They copied some feature engineering notebook and trained transformer XGBoost plus CatBoost with 3 different random seeds with 5 folds each, and it was literally all they did. Yeah, like how to win the 4th place. They also used external data, of course, but I don't mention it as far as it's mentioned in previous slides. I can share my own experience. I did relatively the same thing. I looked at the data like leaderboard, found out the best public solution by Vadim Kamaev, was looking how to improve it, and really haven't succeeded. That was a very like thin solution, hard to improve with just 1 model. But I found an interesting thing that when you submit exactly the same model, but with 3 folds or 5 folds, your score really drops down. And as for me, it meant that we are really overfitted for public leaderboard, because usually this out of fold prediction really improves bias, but not the but do not reduce performance. That's like random forest thing when you can add estimators forever and never get it worse. You just reduce the variance of your prediction. So what I did is I trained my XGBoost model, trained my CutBoost model as Vadim did, used 5 folds for each one as force place, but without transformers, and mixed them up. I haven't really tried to find a proper weights for these models on some like evaluational data sets. I was doing it at the last day, so I just joined everything, submitted 5 different blends, and one of them, one of the best performing on the leaderboard, but still kind of conservative in my terms, got me bronze medal. Waiting for waiting it to be rendered on my profile, because it's not rendered. I cannot write it, about it in LinkedIn, and really anxious that they would forget about it. That's it.
Thank you very much, Dmitrii, for your very nice presentation. So, colleagues, please comments. So the first comment is very good English. By the way, we have checked it. So, for example, YouTube can recognize Dmitrii's English and can create the subtitles automatically. So that means that English is quite good. Okay, so don't hesitate. Any questions, comments, suggestions, whatever. And I can now allow you to unmute yourself. So you can ask a question in chat or unmute yourself and ask by voice. Up to you.
Yeah, we also can, like, if no one wanna ask me, like, for the record, we can stick to like non-recorded questions, also in Russian.
Thank you, Dmitrii, for presentation. Great job.
Thank you.
Okay, any other comment? Yes, Luda, please.
Sorry, it was which period they use from raw data?
Which,
or they don't?
They
which
don't.
they don't say about it.
They don't really write it, yes, but they mentioned that they kind of used, like, you mean competition organizers used some file to use it as a private test or public test, right? You're talking about this thing. They got something from the end, but not from the very end, but yeah, like something in a second third of all the available source data.
People who train using raw data, which months they got from raw that raw data? It was from.
I got it. They got everything they could have and pre-processed everything they could have. It really gives 1 or 200 performance for literally every model they build. And this is like strong trend between first, third, and fourth place. They all write about it. External data was really useful there, and no one was like into data selection. They used everything.
They don't say they use people only if it's no, if student answer all three set of questions.
Yes, they did. Okay, they had the next schema. Third and fourth place don't really write about it, but the first place wrote the following. They got like all full sessions for the stage. So for like first stage, they got every session which really passed the first stage, and they didn't really care about second stage or third stage. For second one, they got like full first, full second, but no additional filter for third. And for third, they got everything. So they might have had their model for third stage to be worse.
Do you remember XGB params?
They don't, as far as I see, they share it, they show it, but it was relatively basic one, like learning rate of 400ths, like 4 divided by 100, and 600 estimators. So no one really tuned it up. Some, no, alpha, beta regularization didn't done any great job for this competition for some reason. Everyone was just stuck in. And like, as far as I see, the reason of it was this gap between public and private test. They had a relatively small amount of sessions there, and as first place writes, they got kind of 1,600 sessions, but you could really achieve stability of scores only at, don't know, 5,000. So yeah, leaderboard wasn't really stable.
Thank you.
Might be a little bit overwhelming.
Any other questions or comments, suggestions? Dmitry, and what was the input data? It was something like a table data, or it was text, or something? What was?
It was event stream. So like you could have session ID for this exact session, and like sequence of events. So like, for example, user clicked at the buttons and user clicked at the screen where nothing really occurred. No, like interactive object really occurred, and he moved his mouse upwards for 50 pixels and so on. User pressed space at his keyboard, such kind of actions.
And what was the targets? The targets was just
yes. So they had. That's a nice question. To be honest, targets were just results of their choice. So as far as choosing some answer from their like notebook from test can be correct or not, but okay, they had just session-wise targets for every question. And yes, it was the target was to predict if the first question would be answered correct, if the second question would be answered correct, based on all actions done before the test time. So like, yeah, user have two states when he freely travels the map and looks for some clues to investigate this problem of the game. And second one is like answer time, when gathered knowledge of child is really tested. Also, first place, they wrote that they read some research article about this open source game. As far as it's educational games, people really write some answers by it. And the purpose of this game was to predict, like to estimate students' ability to read. So they really built some nice features based on how do people read, how nice, how long text occurs, how was it formalized, because this game had some variation. You could have different sentences for the exactly one question.
Okay, so as you say, the input data was a kind of non-trivial. It was not a table data.
Yeah.
So how do people convert it to something which kind of you can train XGBoost on some table data?
So people, yeah, basic features here were some aggregates. For example, how much have user interacted with some object, how much he clicked, and also all the events had like elapsed time feature, which shown how much time have users spent till the last action to like perform this one.
So it was kind of already inside the data, or
Yes.
everybody should cook it by himself in different ways? Or...
So yeah, I got it. You get the event stream, and then you like cook it as you want, perform any wildest rapture at this data, which could help you to predict the answer.
But I guess it was something like a public notebooks which everybody used.
Yes. Everyone looks like everyone used a very similar set of features, and yeah, no one really found some magic features which would give a really great boost. Every feature done its job, but no magic.
Okay, I see.
You also can check out like the best notebooks in my channel, follow, and so on.
Okay, thank you. And so, still, I'm surprised that you said that everybody used XGBoost. So, in my experience, XGBoost, if you run it on GPU, then it can be faster than the LightGBM. LightGBM, you can, it is faster on CPU, but on GPU, LightGBM, it's the same as CPU, so it doesn't give you performance on GPU. So maybe that was the reason people used XGBoost, because they run it on XGBoost or on GPU, or I don't know.
That's a nice question. I don't really know which kind of setup they had on their own machines, where they were validating and training and experimenting and so on. But scoring notebook had only 8 gigabytes of like RAM and 2 CPUs and nothing else, and no access to the internet. So I'm not sure that that's the reason. As far as I know, XGBoost is kind of more popular in some ways because it has relatively nice like default hyperparameters, but LightGBM doesn't have it. But as far as I see on CPU setup, LightGBM is really like even faster.
Okay. How many features, I mean, approximately people have had, I don't know, 10, 100,000 or?
Sure. It was usually hundreds, kind of 600 per question per stage. Yes, some people used kind of 5,000 per question, but I'm not sure it really gives some performance. I haven't seen anyone at the like top of private leaderboard with this setup. It's also part of this validational problem as far as private set is relatively noisy and you could really get some shakeup. So people had to be conservative. They had to really add as small amount of features as they could.
Okay, thank you. Now there is a question in the chat. Does this exercise provide any insights on interventions that the game can apply to improve learning?
I would say this, we will know this in several months when the competition organizers would write up their paper, but people really haven't found any really great insights. They found that, okay, like time users spent on reading of some node really affects how would this user like answer the question based on this node. But it's not like that obvious because some people read fast, some people read slow, someone could go and grab some tea while thinking about it. But yeah, they had no really valuable insights. Everyone was focused on model, and I would say from my side that organization of this competition wasn't that bright, wasn't that great. As far as I see, we got a lot of pain at the Kaggle chat. They even had the most disliked topic at the forum, as Alexander found.
Yeah, unusual, yeah. And another question. So I don't quite get these questions and the answers. They were in this app, or they tested additionally these people somehow. I don't know.
Yes, they tested it inside the app. So you just play for several levels at the like pixel hunting quest. Generate some like events, data, and so on. And after it, at some point of plot, you are just asked in a special window, like game is paused, and you have to answer. So you just answer if you know the proper answer for this question, like who have stolen your grandpa's notebook, who have imprisoned your pet, I don't remember, raccoon, it might be raccoon, who is the stealer who wants to get all your findings and settle them up as their own, something like it. So that's a detective story connected with some kind of history of this like developers town. I don't really remember which one, but there was some about history of feminism, especially suffragists, some part about like ICA flag and like ICA breaks they had in their town and so on.
This is some kind of regular app which everybody can download.
Yes, you can download it. That's a web app. You can play it online even now. As far as I see, everyone who solves this competition really tried to played it one time. The plot is kind of bluntly, but yeah, like different people also in train set you could found that the same people from same like IP could play several times. So there were some person who played 72 times, as far as I see. Ludmila can correct me in these terms. Yeah, like it was one of the relatively useful features to show if person plays second time or not.
About the kind of privacy question, so when you enter this app, you press some button that you agree that your data will be saved, and
Yes,
someone.
They write that it's like for non-commercial purposes, for educational and research. So yeah, you have to agree to share the data.
Okay, and then okay, the data which was in the competition, it was kind of generated by kind of some random people who.
No, usually by school students in like 13, 14 years old. Yes, everyone.
I mean, who forced these people, children, to play that particular app? It was kind of some experiment by the. It's written something organized by the National Educational Agency, so it was kind of government supported, where kind of children come to school and they were said by the teachers, "You must play this game today."
Yeah, kind of, yeah. Like they haven't forced children to really participate in this thing, but if you would ask a 13, 14 years old child if he want to play some computer game or once again seen the American hymn, they would choose playing the game. And the game was kind of patriotic. It tells about the story of the city and about current like Vogue culture. So everything's founded by government.
Okay, I see. And, how many samples? I mean, how big was the data set?
I don't really remember. Ludmila, could you help please with this question? How much sessions have we got? 40,000 as far as I remember.
Okay, around something like
40,000 and another 30,000 at the like public source data. You could really extract it.
Okay.
Did the target include time to answer, what wrong answer was given, etc. No, we haven't really seen any like right answer even from the previous stages when we are scoring something. We also haven't got any time of answer. So every information about answering stage were raised. We just got if the first answer correct or not. Also, I remember about it. I remember another useful thing for the first place. They aggregated all the data in the next manner. Like if person plays several times, they set up first answer is the right one. So if, like minimum of the question by his sessions. So if person played, for example, 3 times and first time he was wrong everywhere, and then played 2 times more and was like right literally everywhere because he's already known. He already knows the answers because they are given in the game. You cannot really answer wrong, and you have to like answer till you right. So they aggregated it and like on the user level, they have several sessions for the same user, but the same set of answers. Because user kind of had some bias, some knowledge about the game. It really helped them to improve some score.
Okay, thank you. Any other comments, questions, suggestions?
Okay, let's stop the recording. Thank you for listening. Thank you for coming.
Thank you very much, Dmitrii. Very nice presentation, and we wish you success in all the competitions and other projects.